In addition to standard constructors, in C++, a copy constructor is a special type of constructor that allows us to make a copy of an existing object. Let's see how this works. Just like an automatic default constructor, an automatic copy constructor is defined for us if we don't provide any copy constructor whatsoever. The automatic copy constructor is going to copy the contents of all variables. Often, this is going to be acceptable for us, but in some cases we want to actually define exactly how the copying takes place or possibly share resources between two instances of a class. To define a custom copy constructor, we need two things to be true. The function needs to be a class constructor, so it needs to follow all of the rules for a class constructor, and it must have exactly one argument, and that argument must be a constant reference to the same type as the class itself. A constant reference means here we have a constant cube passed by reference object. Notice the definition, it's part of the cube class, has the name cube. It follows the properties of being a constructor. Looking at some code, we see that we've defined a default constructor up here. This is exactly what you saw last video. And we defined a custom copy constructor down below. This custom copy constructor takes in an object, and the goal is to copy the contents of the object into our current instance. So notice we have an object.length equal to our current length. Since that's the only variable, that's all this function needs to do. In this case, the automatic copy constructor would do exactly this. So there is no need for us to define an automatic copy constructor here, but you're going to find it as we build data structures, we need to define custom copy constructors. A copy constructor is invocated automatically in almost every case. Times that it is invocated is when we pass an object as a parameter by value into another function, or if we return an object by value from a function. Initializing a new object from a previous version of an object will also invoke a copy constructor. Let's see examples of all three of these in code. So that we can actually understand what's going on, I've added a little bit of code to our cube.cpp class. In addition to providing the functionality of setting the default constructor having a cube of length 1 and having the copy constructor copy over the contents of the length, I've added a cout statement to say exactly what's been invoked. Whenever we call our default constructor, we'll print out default constructor invocated. Whenever we call our copy constructor, I'll print out copy constructor invocated. This way, when we run our program, we'll see exactly what code is running when we have a set of source code. Here in our first example, we have a main.cpp. Our function main is here on line 15. We create a cube on line 16. Creating a cube is going to invoke a constructor. Here, this is going to be the default constructor. Finally, on line 17, we call foo. Foo takes in a cube as an argument. Because this argument is being passed into a function, we know it has to be copied from main into the foo stack frame. We expect the second call to be made is a call to the copy constructor. So when we run this program, we expect a default constructor to be called first, and then a copy constructor to be called next. Remember, we've annotated our class so we know exactly when these are being called. So let's go ahead and run example 1 and see what happens. Going into the CPP copy constructor directory, moving into example 1, running make, and then running /main. We see the default constructor is invoked, followed by a copy constructor. This is exactly what we expected when we evaluated the code. Let's go take a look at a second example. In this second example, we're going to again start at main and see that cube C2 takes on the return value of foo. So right now, nothing's being created. So we need to take on the return value of foo. So we're going to go ahead and jump up to cube. We're going to go ahead and jump up to foo. In foo on line 12, we have a cube created on the stack. So this cube is going to call the default constructor. And then the second thing, we're returning this cube back to main. So similar to our first example, we have an object in foo. We need to copy it over to main so that main can make use of it. So the second thing we're going to see is going to be a copy constructor. Now that it's back in main stack frame, we need to do something with this variable. And here on line 17, we see that C2 needs to take on the value of what's returned by from foo. So we expect the third copy constructor to copy from the main stack frame into the variable C2. What we expect to see when we run this program, 3 lines of output. Default constructor, copy constructor, copy constructor. The first copy is to return to the main stack frame. The second copy is to put it into C2. Once it's in C2, we can then work with that variable. Let's see what happens when we run this program. Moving into example 2, running make, /main, default constructor, copy constructor, copy constructor. Awesome. Looking at a third example, we have another program here in main again, and on line 12, we create a cube C. This calls our default constructor. And then on line 13, my cube needs to take on the value of C. Again, because we're initializing this variable, and this variable is taken on the value of C, the value in C is copied into my cube. So we expect the second thing to run to be a copy constructor. So in example 3, we expect a default constructor and then a copy constructor to be called. Let's see what happens. Moving back and moving into example 3, running make, then running main, default constructor, copy constructor. Exactly what we expect. Let's look at one last example that's going to do something slightly different, even though it looks very, very similar. Here in example 4, we have the exact same code as example 3, but somewhat rearranged. So here on line 12, we create a cube. This is going to call a default constructor. In line 13, we create another cube called myCube. Since this is creating a cube and not being assigned from anywhere, it has to call the default constructor. Finally, on line 15, myCube takes on the value of the cube C. We might expect a copy constructor to be called, but here, both myCube and C have already been constructed. They've already been created by different default constructors. A constructor's job is to actually create the object itself and not just copy things between two existing objects. I don't expect anything to get printed out here because we're not doing any construction. We're just doing copying. So because it's just an assignment and not a construction, because myCube was already constructed here, unlike the previous example where myCube was constructed at the time it was being assigned, I expect the program to output default constructor, and nothing else. Let's see what happens. Moving back, going to example 4, running make, and /main, we see that 2 default constructors are invocated and no copy constructors. This is exactly what we expected. And to understand why, we'll dive into what it means to have an assignment operator in the next lecture. I'll see you then.